Good afternoon, participants. The session will be started within few minutes. Good afternoon, participants. The session will be started within few minutes. Good afternoon, participants. The session will be started within few minutes. One kind announcement for everyone. The participants who are all filling the attendance and feedback link, do fill it properly. Put participant ID correct so that we can mark your attendance. Those who are putting dot, they will not be eligible to get certificate. So everyone, please check the participant ID and put it correctly in the feedback form. Thank you. And the meeting will be started within few minutes.
Hello.
Sir, good afternoon, sir.
Good afternoon. Yes.
Sir, shall we start, sir?
Yeah, we can start. Yes.
Thank you, sir. Thank you very much, sir. So, very good afternoon, participants. So, welcome to day 3, AICT ATAL sponsored FDP on IoT for Smart Cities, organized by Department of ECE, Ungaladu College of Engineering and Technology. Today, our resource person, Dr. T.N. Raj Viknesh, Chief Technical Officer, so Scilabs Electronics Engineer, Salem. Welcoming, sir.
Thank you, sir. Thank you.
Yes, sir. So before going to start the session, so I would like to Rakesh to introduce our chief guest.
Yes, sir. You don't change people's mind by the words you speak, but you inspire change in their hearts by the life you live. We cannot think of a person more suited to this than today's chief guest, Mr. T.N. Raj Vignesh, IoT Solutions Architect, catalyzing enterprising digital transformation. Before going to the session, let me know you the short intro. He completed his UG degree in Electronics and Communication Engineering from Sona College of Technology, Salem at 2011, and he completed his PG degree in Real-Time Embedded Systems from Coventry University, UK at 2014. He is an industrialist who have the knowledge and skills in both software and hardware such as embedded C, C++, Python, VHDL, RTOS, and various wired communication protocols. And he has the tool efficiency like Kale, MATLAB, Visual Studio, Proteus, Diptrace, and etc. He have 9 years of industrial experiences. Among this, he has worked in different fields like Chief Technical Officer, visiting research associate and R&D engineer in various college and companies. He did the various projects in his curriculum and got the 4 patents for his projects, mainly in the field of vehicle monitoring and communication. He represented the paper in several conferences and also published in journals. He was selected as the finalist in Intel India Embedded Challenge at 2010. He was one of the best outgoing students of the college during his UG degree in 2011 and also received MS Ramaiah Gold Medal during his PG degree in 2014, and also he was certified as the HAM radio operator by the Government of India Wireless Planning Commission. He is such a legend who has succeeded even from his study. Now I request our resource person Mr. T.N. Raj Vignesh to deliver his speech on the topic IoT for water distribution in smart cities. Please, sir.
Thank you. Good afternoon, everybody. So I would like to start this session with a small interaction with all of you about your understanding of Internet of Things and possible applications of Internet of Things about today's topic, water distribution networks in smart cities. So I would request the host to unmute the participants who would like to take part in this dialogue. I would like to know what is your understanding about IoT and how IoT can be applied for smart cities. So I would like to take a fundamental understanding, and based on the understanding, I would like to structure today's session. It's going to be interactive. It's not going to be a monologue lecture. Please. Anybody, please come up with your understanding about IoT. Just a two-liner about IoT. Anybody? Anybody interested in responding? I see somebody has request for unmute.
Hello, good afternoon, sir.
Good afternoon.
Hello, sir. I am Dr. Madhuri Mule. I am from civil engineering background. So I am very much interested in water distribution network, sir.
Okay, fine.
I have done my
Fine,
PhD.
Dr. Madhuri.
Hi, sir. I have done my PhD in water distribution network, sir. And I have used WaterGem software for that, my PhD project.
Okay. So yes, Dr.
So I am very much interested in how the IoT used in water distribution network, how it is useful in because I am from civil engineering background, so I don't know about the sensors and everything, sir. So please you guide me so that I can have some knowledge about the sensors and everything. So
Sure, Dr. Madhuri. So
yes.
today's session is going to be on efficiently monitoring a water distribution network for smart cities. Because when it comes to city and delivering, hello? Yes. So when it comes to smart cities, delivering water door to door, maintaining the quality and quantity of the water, delivering water at the right time is not a simple task, because water source will be a couple of them for the entire city. And from that couple of water sources, maybe a reservoir or pond or overhead tanks or even the river directly, the water has to go to the tail end of the city. And a city, geographically, topographically, it has various contours. It has various ups and downs. And delivering water to the tail end, maintaining the same level of quantity and pressure is not a simple task. It takes a lot of design effort and intellectual thinking to design the water distribution network, to see where proper pumping stations, proper boosting stations are to be provided so as to enable water delivery across the water network. So as you said, you have worked on water distribution networks already. You would probably know that the significance of the pumping stations in the water distribution network. So here today we are going to see how to remotely monitor and control a pumping station microscopically. So a pumping station is the building element or the fundamental block of a water distribution network. So today in our session, we are going to see how a pumping station can be controlled. Now, when it comes to water distribution networks, there are water tanks, water sumps, reservoirs, which are the main source of water. And we have the pumping stations. Finally, the pipeline size reduces from the pumping station, right from the pumping station, and goes to the tail end houses. So if you take the houses, the pipeline size will be somewhere between 3/4 of an inch to 1 inch, not more than 1 inch it will be. For some apartments, the pipeline sizes are like 2 inches to 3 inches. And to some greater commercial complexes like malls, the pipeline sizes are like 2 to 3 inches. But if you take the main distribution line from the reservoir, the pipeline size will be about 8 inch to 10 inch, or even sometimes 12 to 20 inches in diameter. So what happens, this varying sizes of the pipeline, right from the head end system to the tail end delivery point, there are various pressure that has to be maintained. You cannot maintain the same pressure from the head end to the tail end. So there are pressure gauges here and there, every distribution point. There are water meters to monitor and measure the quantity of water that is flowing. So various components are there. But for today, we are going to see how a pumping station can be remotely monitored and controlled, because efficiency of pumping involves maintaining the proper pumping efficiency, maintaining proper quantity of water in the every pumping station and all that. So today in our session, I am going to discuss in detail about how IoT can be used to remotely monitor, control, and automate a pumping station. Because these pumping stations are somewhere in the dark, or somewhere inside the jungle. They're very close to the water source, say the river or reservoir. So what happens? These pumping stations are inaccessible for human intervention frequently. So you cannot have a person sitting there to monitor and control the pumps and all that. So what we are going to do today is to use IoT to control, monitor, and schedule, and also automate the pumping stations. So give me a second so that I can share the presentation with you. Yes. So as I take a while to connect my screen to the system and share it with you, I'd like to understand how many of you have an idea about the pumping stations. Typically, what are the components that could be there in a pumping station in a water distribution network? I would like to have your imagination and understanding about the pumping stations. Please, somebody respond. Anybody? Any idea of what are the instruments or machines that will be there inside a pumping station?
Hello.
Yes.
Sir, various types of pumps are there in the pump rooms. Then various types of valves are there.
Okay.
Then meters are there.
Okay. Okay.
Then
Yes, you're correct. So there are valves, there are meters, there are pumps, and additionally there is a water sump, because pumping station needs to have a water source, and it will not simply pump and deliver. It will store the incoming water in a sump and then pump it and then again deliver.
It is a master balancing reservoir, sir. MBR.
Yes, yes. So these are also called as booster stations. So
Yes.
we will be looking at it right now. Give me a second as I connect the screen. Dr. Yuvraj, I'm not able to connect from my other device to present the screen.
So you're joining by other ideas, sir?
I'm joining from the same ID only from another device.
Okay. So what is the same name is in that radio, sir?
Give me a second, let me check.
Excuse me, sir. Hello, sir. Dear participants, stay in the line. The resource person will join.
Yeah, extremely sorry for the inconvenience. I have some issues from my laptop. I'm not able to join from it. However, I've shared the presentation and the link to the host. So they will share the presentation on the screen right now, and we will continue this session. Dr. Yuvaraj, I've shared the PPT with you. So please share the screen.
Yes, sir. Just now I received. I will share it now.
Yeah, please.
Okay, thank you.
Am I audible?
Yes, sir. You are audible, sir.
Yeah, okay, fine. So thanks for sharing the screen. So today in our presentation, we are going to see, can you make this full screen?
Yes, sir, just a second, sir.
Yeah, thank you. So today in our presentation, we're going to see about how a pumping station can be automated. This is the smallest of the integral elements of a water distribution network. It is very, very vital that a pumping station be monitored and managed promptly so as to achieve complete efficiency of the water distribution network. A water distribution network consists of multiple pumping stations connected in a network. So one pumping station will deliver water to two others, or even one other, or even many other pumping stations. From there, again, water will be taken and forwarded to the others. So like this, water will travel from the riverbed or from the reservoir to the tail end of the houses. So we get drinking water, water supply intermittently. So a complete entire network is being operated behind that. So in order to achieve complete efficiency, we need to ensure that the pumps are running at optimal current, optimal pressure and all that. So today we are going to see how a pumping station automation is achieved. Next slide. Next slide, please. So we can move to the next slide. Yeah, thank you. So this is the idea here. We are going to automate the pumping stations. In the pumping stations, we will have water pumps, pressure gauges, flow meters, water tanks, and all these need to be remotely monitored and controlled. So major important components of the pumping stations include water pumps, like the ones you see on the image on the left hand side. So those are centrifugal pumps. And what happens if you don't properly streamline the pumping stations, which means one pumping station connected to two other pumping stations, if you don't optimize all of the three all together, what will happen is, if one pumping station stops receiving water, or if there is a pump failure in one pumping station, the previous one delivering water to it will keep pumping water quantity at the destined pressure, and there will be a pump burst or a line burst. Line burst is a very, very serious thing in a water distribution network. Once a line burst occurs, it takes a lot of time, effort, money, and energy to fix it. Until then, water will not get delivered to the consumers. Finally, the motive of having an efficient water distribution network is lost. So much of water will be lost that before you go to the field and start fixing the broken pipes and lines, you will have lost gallons and gallons of water. So it is very important that all the pumping stations in a distribution network are optimized and controlled from one central point and scheduled accordingly. So this is why we are in the necessity of automating a pump station through IoT. Next slide. Next slide, please. Next slide. Next slide. So this is the solutions abstract that we are talking about. Currently, what is happening in a manual pumping station is this. Manually operated pumping stations engage operators in shifts. So they use manpower, and that person will stay there in the pumping station regardless of how interior that particular location is. He will stay in the pumping station and he will receive phone calls from his higher authorities to turn on the pump, to fix the pressure, to tell the water level, tell the quantity of water being run out from the pumping station and all that. So we need 2 to 3 shifts of people working there to efficiently monitor and maintain the pumping. So this is one big headache now. Suppose this person goes on leave or he falls asleep in the in the night time, there is a lot of chaos and havoc happening, that he is not able to monitor and control or administrate the pumping station. Moreover, when there is one pump station blast happening, for the message to be conveyed to the other pump station, it has to go through hierarchy. So there is a supervisor, there is a pump station operator, there is an assistant engineer, and then there is a regional chief engineer or somebody like that. So the message has to be conveyed to all of these people. And again, the other pump station operator should be made notified about the failure of the other pump station, and this pumping has to be stopped, or the plug has to be pulled accordingly to prevent burst or wastage of water in this particular pumping station. And second thing is event reporting, shutdown, line bursts are not reported properly. So people don't know when you will get water and when you will not get water. Today's target of the central government is to provide 24/7 water supply to across all the homes. So that is the target for today's government, and we are moving towards that. That is why we are discussing about this topic today. For this to happen, we are to be notified of the shutdowns, we are to be notified of the quantity of water delivered from the pumping station and all that. So for that, we are going for the solution that we will connect the pumps, water level sensors, electromechanical valves, and flow meters to a web server through an IoT gateway. So we will share some intricate details about the IoT gateway. Before going into the details of the IoT gateway, I would like to know who has an understanding of IoT gateways. What are IoT gateways and what are their significance? Can somebody throw light on this, please? So we can stay in the previous slide, please. Thank you. Anybody has an understanding of IoT gateways, please open up. Anybody has an idea of IoT gateways? So IoT gateways filter, store, and ingest data. Yes. Somebody else? I request all the participants to keep this session engaging, please. Any idea about IoT gateways? Yes, I'm getting answers. Collection of data, IoT gateways, port through which all the end device get connected, processing the data. Yes. So IoT gateways are meant for conveying real world happenings to the computer or to the internet. So first thing is a real world happening can be anything. It can be a flow of water. It can be, in this case, if we specifically talk about, it can be a flow of water. It could be the quantity of water that is being pumped out. It could be the pressure in the pumping line. It could be the number of hours the pumping has happened. It could be the level of water in the tanks and the sumps or in the reservoirs. So these are real world happenings in our use case that we are discussing today. Generically, if we take a real world happening, it could be a temperature, it could be humidity, it could be a moving vehicle, location of the vehicle, it could be the fuel consumed by the vehicle, it could be the loudness at which I am talking right now. So all these are real world happenings. IoT gateways are used to collect all these real world happenings, data from all these real world happenings, and send it to a server. That is why it is called as a gateway. It is a gateway to the internet. So once data is available on the internet into a server, we will have the advantage of analyzing it, monitoring it, and reporting it in different perspectives. So that is what we are going to do today using the IoT gateways in this application. So for any real world happening to be understood by an IoT gateway, we need to convert the real world happening into a digital data, because these IoT gateways take data from the digital data as input, and they send it to the server over 4G, 3G, 2G, or LoRaWAN or NB-IoT, different protocols. So this is the purpose of an IoT gateway here. Today, for this purpose, we have chosen an universal IoT gateway. We will be discussing about that shortly after this slide. But in essence, we are going to use IoT gateways and sensors and actuators to control and monitor the components of the pumping station. So the components of the pumping station are, as you can see in the slide, those are pumps, there are level sensors, there are electromechanical valves, and there are flow meters. 4 components are there. Pumps are meant to suck water from one source and deliver it to the other. Electromechanical valves decide how much quantity of water will flow through the pumping line. As you regulate the valve, the water quantity will be regulated as well. Then you have level sensors that tell the quantity of water available in the reservoir or pond or overhead tank or in the sump, wheresoever. And finally, we have flow meters, which measure the quantity of water that has flown through the pipes. So these are the 4 components that are being connected to the IoT gateway, to the server through the IoT gateway. Through this, what we are trying to achieve is pumping hours can be automated and scheduled. So I don't have to rely on a person, call him and tell, start the pumping at 4 o'clock in the morning and end the pumping at 6 o'clock in the evening. I don't have to keep telling that person like that. I can simply schedule it. Once the data is available online, once the pumping station is connected through the IoT gateway to the server, I can set the schedules and set the schedules automatically. So what will happen is once I have set the schedule, the pumping station will be automated accordingly. Automatically, the pumping station will turn on and turn off at the scheduled time every day. Second, the operation modes can be decided between manual from server, automatic scheduled, automatic level based, and manual on field. So 4 types of operations are available. Number 1 is manual from server, automatic scheduled, number 2. Number 3 is automatic level based, and 4th one is manual on field. So we'll go one step at a time. Manual from server. Manual from server means you will be lively monitoring the pumping station from the server through a web application, and you will click the button to turn on and turn off the pumping, to read the water level in the tanks or sumps, to see what is the percentage of has opened the water flow through the electromechanical valves, and you will also see what is the water level in the thing, and you will also see what is the quantity of water flowing through the water meter. So this is manual from server. So instead of having a person sitting in the pumping station itself, you will have a control room in some office, and you will have a person sitting in front of the computer, and he will manually click to turn on, turn off the pumps and all that. Second mode is automatic scheduled. Means I will set a schedule on the web application and simply forget it. It will keep repeating the schedule every day. If I set a schedule for morning 6 o'clock to 8 o'clock, every day it will follow the same schedule. So that is automatic schedule. The third one is automatic level based. So what I will do is I will give a setting telling, see, if this is the level, this much of pumping has to happen. So if the level goes below that, again, this much of pumping has to happen. If the level is beyond, or if it is more, then the pumping has to stop. So this is called automatic level based. And finally, manual on field is the conventional mode of operation. You can send a person to the pumping station, and on field, you can, start, you can control the pumping station. That's what is conventionally happening. We keep a room for that also, because sometimes there might be manual intervention might be required in terms of maintenance and other downtimes and all that. The third aspect of this solution is events can be logged and reported instantaneously. So events could be anything. It could be a line burst. It could be a loss of pressure. It could be dry tank. There is no water to pump at all. And finally, the most critical thing is when there is a dry tank, if the pump starts working again and again, in a dry line, if you keep the pump running, the coil will burn out and the pump will go off. So this events can be logged and detected and reported instantaneously. So instantaneously, when there is no water, when there is dry pump running, So we can send a mobile alert or SMS alert to the concerned authorities, and they can take immediate action to turn off the pump to prevent the pump from going into a mode of failure. So these are the three aspects of the solution that we are going to discuss today. So in short, we will be connecting pumps, valves, level sensors, and flow meters to a web server, and that web server will be running a web application as well. And this web application will have provision for the user or the control person to turn on and turn off the pumps, to check the water levels, to check the pressure levels, to see what is the quantity of water being delivered. So why we should measure the quantity of water being delivered is because to identify and understand leakages. So one pumping station gives 1000 liters per minute pumping rate, and the other pumping station receives only 800 liters per minute. Definitely this 200 liters per minute is a very big quantity that is being lost somewhere in between. This could be because of illegal tapping, or it could be because of a leakage, or it could also be because of an inefficient pumping line with too many ups and downs and all that. So this gives you information whether the water that you are pumping is properly getting delivered to the end destination or not. So this is the aspect of the solution that we are presenting right now. Next slide. So these are the components of the solutions. We have the sensors. Sensors are meant to measure the water level in the tanks and the pressure level in the pumping line. So these two sensors we are using, and of course actuators we are using to turn on and turn off the pumps. These pumps are operating at 230 volt and they draw heavy current. So we will use high current relays to control the pumps, to actuate the pumps. And then we have servo motors on top of electromechanical valves. These motors will rotate to open and close the valve automatically when there is an electrical signal coming from the IoT gateway. So all these sensors and actuators will be connected to the gateway. There will be a SIM card inside this gateway. It is working on cellular technology, so it can be deployed anywhere across the country wherever there is cellular coverage. So all these sensors and actuators will be connected to the IoT gateways. Then the third component is a server setup where it is running on the cloud. The application, it's a cloud-based server, and we have a web application running on the server from where you can monitor and control the pumping station. So that is about the server setup. And finally, we have the software. We have mobile applications and web applications, which will be given to the concerned authorities. They will be able to monitor the pumping stations from their mobile and web application. Shortly, I will show the web application that is built for this particular purpose. So these are the four components of the solution. We have sensors that are connected to the IoT gateway through wires. The sensors and IoT gateways will reside in the pumping station. IoT gateway has a 4G SIM card inside. It will connect to the cellular network and start communicating to the server setup. So this server setup will be running on the cloud. It will receive and send data to the IoT gateways. It will receive data from the IoT gateway and send command to the IoT gateways. So command is to turn on, turn off the pumps, to read the water level and on all that. And receiving data will be automatically every minute. These IoT gateways will send current status information, the current status of the pumping station, that will be sent to the server, and the server will be receiving it. So these are the four components of the solution that we are talking about. Can you please open the other PDF that I had shared? It is a data sheet of the IoT gateway. Sir, can you please open the other PDF that I had shared? Thank you. So this is the data sheet of the universal IoT gateway that we are using to control and monitor the pumping stations. Can you please zoom in? Zoom into the technical specifications. Yeah, thank you, thank you. Thank you. So this is a universal IoT gateway, meaning IoT gateway can be used for various purposes. If you see, it has a processor, it has memory to store the data, it has storage in the form of a non-volatile EEPROM. There is no operating system on top of this IoT gateway. It's just a simple IoT gateway. And it has communication options like Wi-Fi, GPRS, NB-IoT, 4G, and LoRa. There is an antenna for radio communication purposes. It can be externally power supplied through 110 volt to 230 volt AC or 24 volt to 30 volt DC adapter. And interfaces like RS-232, RS-485, 4 to 20 milliamps are all available. So this is the technical specifications of the IoT gateway. Let's have a look at the image of the IoT gateway. We can move to the next page. Let's move to the next page, please. Yeah, thank you. So this is the image of the universal IoT gateway. You can see on both sides of the image of the product, there are screw terminals into which you can wire the sensors and actuators. So there is a pump, you can connect the pump to this device. There is a tank level sensor, you can connect the tank level sensor into this. There is a pressure sensor, you can connect that also. And there is a water flow meter, you can connect that water flow meter also through this screw terminals. And then you can put a 4G SIM card inside and it will directly connect to the server. And it currently we are operating on a protocol called MQTT, Message Queue Telemetry Transport. So this is the protocol we are using to connect the sensors and actuators to the server. We can move to the previous presentation.
Okay. So,
Yeah, we can move to the slide where we left. Yeah, next slide, please. So these are the four components that we will be controlling, connecting to the IoT gateway. There are centrifugal pumps. There is an actuator or valve that will regulate the water flow. There is a sump or tank that will intermittently store the water and then try to suck and deliver it outside. Then finally, there is a water meter that will measure the quantity of water being pumped by this one pumping line. So one pumping line consists of a pump, an actuator, a tank, and a water meter. So four of these devices will be connected to the IoT gateway that I just mentioned, and data will be brought online. Next slide. We can move to the next slide. So as I was mentioning, there are different kinds of controls that are to be achieved because we need to have redundancy in our approaches. If we don't have redundancy, if one method fails, the complete pumping station will be out of control and it will be like a satellite that is not in the orbit. It will be going chaotic and it will behave by itself. So to avoid that, we are providing different operation modes. If one fails, we will go with the other. The first and the simple thing that is already available is on-site manual. So this is a conventional manual control from pumping station. So you will send the person to the pumping station and he will control the pumps. He will take the reading from the sensors. He will take the reading from the water tanks and all that. So this is the final approach that we will take when every component of our automation fails. We will resort to this mode. Second one is automatic scheduled. It's automatic pumping based on preset schedules. So schedules will be set to turn on the pump at a specific time and turn it off at specific time. And it can be set for every day also. Like Monday, there should be a schedule. Tuesday, there should be a different schedule. Wednesday, Thursday. So every day of the week, there could be a different schedule. Once the schedules are set, every day the same schedule will repeat. So you don't have to remember it at all. The system or the IoT gateway will remember by itself and it will take care by itself. Then we have remote manual, means you will have a laptop or PC in your office. You will open the web application and manually, remotely, you will be turning on and turning off the pumps and you will measure the water level. You will take decision accordingly. If the water level is dry, if there is no water, you can stop the pumping and you can see the quantity of water that has flown. If you think that enough water has flown, we can stop the pumping. You can stop the pumping. If you think enough water has not flown, some more hours of pumping is required, then again you can keep the pump running and all that. So that is remote manual. Finally, the most advanced thing is automatic hybrid. Automatic pumping based on hybrid rules involving water level, schedule, pressure, and quantity of flow. So what will happen is we will be writing a fuzzy logic on the cloud server in the web application involving different rules. For instance, there could be involvement of water level, there could be involvement of the pressure, there could be involvement of the quantity of water flown also. So keeping all this, you can write an if and else if ladder kind of use case in your programming, and that is called a fuzzy logic. Based on various parameters, the pumping will happen. For instance, you can say if the water level in the tank is more than 50% of its capacity, and if the pressure is only 20 psi in the pumping line, and if the water flown is less than 200 gallons per day, then you turn on the pumping. Otherwise, turn off the pumping. So all these kind of fuzzy rules can be written, and based on the rules, the pumping can happen. So this is the most advanced kind of control that's called automatic hybrid. All these events, anything that is done from the remote on-site manual person or from the remote server manually or from the remote server automatically or something in a hybrid way, all of this, are logged into the IoT gateway, and the IoT gateway keeps reporting all this to the server. So end of the day, we have a complete activity list that happened in the pumping station that we will have an access to see and see where what went wrong, why the pumping was stopped, why the pump had failed and all that. So this is the advantage of this kind of a pumping system. Next slide. Yes, this is the application showcase. This is a sample application screenshot that is there. We have a web and mobile compatible application where you can log in and control the pumping station. So we have a responsive dashboard to control the pumping station, and you have dedicated logins for each pumping station. For instance, there could be one person in charge of one pumping station, one person in charge of more than 5 to 10 pumping stations. We can group all that pumping stations under that particular person's login and let him have a complete view of all the pumping stations that he is in charge of. So this is the kind of application that we are providing with the IoT gateway. I will give you a walkthrough of how the application is working right now. Next slide. The goal is to turn data into information and information into insights, because in data we trust just next to God. So data is very, very important. It will tell you a lot of story, but only if you are able to perceive, if you have perceptions to see it. So if you see data from different angles, you will get different stories. It conveys a lot of information to you. So once we have data from all these pumping stations, it will give you different stories of why a pump failed, why it is drawing more current, why there is no pumping efficiency at all, where the water is getting lost, why there is a leakage. All these kind of stories the data will tell you. That is the ultimate motive of having these pumping stations controlled through IoT. Once you control it through IoT, all the data is there in front of you on a single screen. You can put different data models on top of it. It is a big data. You can apply different data models and see what response it is giving you, and analyze why a particular pump has failed in case of a failure, why there is no water reaching to a tail end point. Suppose there is a tail end village in the pumping network, it is not receiving enough amount of water. This data will tell you why enough amount of water is not going into that particular village, where something has gone wrong, why it has gone wrong, how you can correct it. All that information it will give you, and it will give you a big advantage of reduction in failure cost. If a pump goes off, if the coil burns, thousands and lakhs will be spent on setting right the centrifugal pump. So this cost can be avoided. Dry running can be avoided. When there is no water and still pumping is going on, the coil will burn out. This can be avoided, and you will save a lot of cost in preventing the pump getting repaired. And if you detect that the pump is drawing more current, you need to see why the pump is drawing more current, whether one phase power supply is not there, or whether there is something wrong. There is some blockage in the pipe that it is drawing more current to do the suction and delivery, all that. So it gives you a lot of information on how your pumping network is efficient, whether it is efficient or not. So this is the motive of this project, and we will now be moving to see applications, the application screenshots. Before that, we will see some of the features of the application and benefits of the solution as well. We can move to the next slide, please. Yes, as I was mentioning, in the web application, now we are just moving into the features of the web application as well. There is a hierarchical login access. There is one super admin. Then under the super admin, there are some executive engineers who are in charge of the pumping networks. Then there are some assistant executive engineers who take care of few pumping stations. And then finally, we have individual pump station logins for individual pump station operators. So individually, you can log in and see what is happening with every pump station. If you talk about the assistant executive engineer level, there are few of the pump stations are coming under his purview. He is in charge of 4 or 5 pumping stations. He can see the holistic view of the data from all the 4 or 5 pumping stations. So this will give him an information like pump station 1 is operating fine, pump station 2, there is a downtime, there is some maintenance going on. So we need to stop pumping from the pump station 1 and redirect the water from pump station 1 to directly to pump station 3. So all these bypassing can be done, and he can take the mode of, as I was telling, he can take remote manual access mode and reroute the water from one pumping station to the other. So this is the advantage of having a hierarchical login access. The super admin will have complete view of the entire water distribution network. He will know which station is down, which pumping station is on, how the pumping efficiency is, how much amount of water is reaching which village, which corner of the village, how much quantity of water is getting delivered. So all this can be monitored by the super admin. He has a complete one screen view of the entire water distribution network. This is the advantage. Next slide, please. So these are the benefits of the solution that we are talking now. Reduced downtime, as I was telling, if you prevent the motors from running dry, then you are preventing it from failing. Once you prevent it from failing, there is no runtime, so there is no downtime of the pumping station. If you don't do this, frequently every now and then the coil will burst, the coil will burn, the pipeline will burst, and downtime will be there for 1 or 2 days until the motor is being repaired, the pump is being repaired. You will not be able to do the pumping, and the villages that are the towns that are anticipating water from your pumping station will start starving. So there is no downtime at all. We will reduce the downtime. Reduced manpower cost. Imagine for a state like for bigger states like Karnataka, Tamil Nadu, and all that. Of course, for any instance, for that case, any state, a complete water distribution network of the entire state is there. Imagine how many people would be engaged and how much of cost will be spent on manpower only to keep the water distribution network running. So all this will be reduced. We need just to have few supervisors here and there. Otherwise, the entire control is coming onto the single screen to the server. So the manpower cost is cut. Prevention of failure, as I was telling, once you detect an overcurrent or dry run, you will stop the motor from running, and henceforth you will prevent failure of the machine. Reduced NRW. NRW means non-revenue water, which means any water that is properly delivered to the consumer is called revenue water, because people are paying tax for water in our country. So whatever water being delivered to the consumer for the public is called revenue water. Whatever water being wasted on the roads because of pipe leakage, whatever water being stolen through illegal tappings, illegal pipe connections, is called NRW, non-revenue water. So you will reduce the NRW by identifying the difference in the water quantities between two pumping stations and the pressure levels. So with the help of pressure levels, you will see where a breakage or where an illegal tapping has happened. So with that, you will be able to reduce the non-revenue water. Insights. So this complete solution will give you insight on how efficiently you are running your pumping network. You will not have that information at all with ordinary pumping, conventional mode of pumping operation right now. So you don't know when the pumping station gone off, which pumping station gone down, when it was repaired, when it was brought back to life, how much liters of water is being pumped by every pumping station. You don't have an information about that at all, unless you keep writing it in your diary and put all this data on an Excel sheet and do some analysis, dirty analysis and all that. But now with this web application, you will have complete insights on when, what, where happened. All that information is there in front of you. So you will have in-depth understanding of how your entire water distribution network is operating efficiently. Data modeling. You have big data over a period of time. You will model and see which village, which town requires how much quantity of water per day, per month, how it can be planned during rainy seasons, how water can be conserved during rainy seasons, how it can be efficiently used to drought prone areas or dry areas or during summer and all that. So complete data modeling can be done, and you will have first hand information on which city requires how much amount of water in which month of the year. So once you have this data, you will also be able to plan the water storage areas. Suppose you identify that however efficient the pumping network is, a particular village which is a dry area, does not receive enough amount of enough quantity of water, then you can plan water reservoirs and rainwater harvesting plants for that particular village or town alone. Thereby the underground water table will increase. You can plan to create new ponds, lakes inside that city or village or town. So water will be collected there, and the local people can make use of the water from that artificial pond or river or lake, and that's how it can be planned. So you will be able to judiciously supply water fairly to all the cities and towns. Now there could be one small town or city or village receiving too much quantity of water, more than what is required. Surplus quantity of water might be supplied, and the other village which is just adjacent to it might be starving without sufficient quantity of water. Once you have these data models on your table, you can decide and reduce the quantity of water being flown surplusly to one village or town and move it to the other. So fair and uniform amount of water supply can be ensured. So these are the advantages or the benefits of the solution that we are talking about right now. Next slide, please. Look at the cost comparison or the cost expense that the difference before and after this automation. Before automation, if you see, there are about 2 shifts of people operating a pump station. So there are night shift operators and day shift operators. And for operating one pump station per year, it takes about 2,40,000 to be paid to the resources. And after this automation has been implemented, see, the manpower can be reduced, and the cost can be brought down to 50% of it, 1,20,000. So imagine if this is the cost cutting, 1,20,000 is the cost cutting for one pump station. For a state like Tamil Nadu, we have about 15,000 pumping stations across Tamil Nadu. Major pumping stations I'm talking about. So if you say we conserve 1,20,000 rupees per pumping station per year, you can just multiply. It becomes a very, very massive number. This will be an expense conservation for the government, and this can be utilized for creating new water reservoirs and local water supplies to the towns and village panchayats. So this is the significance of this particular solution that we are talking about right now. You can close this presentation. Now we will go for the live demo of the application.
So shall we close the presentation?
Yeah, you can close the presentation.
Okay, thank you.
I'm sharing a link with you. Please open that IP address. You can open the application and show the login page. I have some 5-10 minutes buffer, or we'll have to wind it up at 4 o'clock sharp.
பாரதி சார் அங்க பாருங்க நீட் இதுமா இது போயிட்டு இருக்கு நீ Sir, that IP address is not get opening, sir.
Let me check. 104.
So 104.237.2.
Give me a second. Give me a second, please.
Okay.
Sir, I've shared the correct IP address to you. Please open it.
Okay, sir, correct?
Yeah, this is correct. So this is a web application that we have right now. So this is an application for a pumping station that has two pumps, one valve. So which means one pump is for redundancy. It's a backup pump, and the other one is the main pump. Then you have the valve. Then you have the water level sensor, and you have the power status. So these IoT gateways are powered from the mains power supply. But when there is no main power supply, these IoT gateway should be battery powered. So we are giving them a 24-volt UPS kind of battery also inside. So now you can see the status power is not okay, which means there is no power supply from this pumping station. And henceforth, the IoT gateway is working on 24 volts. That is why both the pumps are off. There is no power supply. There is a power shutdown in the pumping station. Both the pumps are off and the valve is closed. There is no water flowing. Water quantity is also dry because there is no water in the sump in the pumping station. So this is it. And if you see the local or remote access mode, the mode is set to remote access mode. You can see the icon from there. And then you have the device status. Finally, you can see it is in automatic level mode. So remote access automatic level mode means based on the water level in the pump, in the tank, the pumps will turn on and turn off, and the valve will open or close automatically. So you can see on the bottom right hand side, you can choose the modes between automatic level mode, automatic timer mode, and manual mode. Can you please scroll down, sir? So in between, you can see the water tank level, the minimum level and the maximum level can be set. There are setting provisions there in between. Because every tank level in every pumping station will vary, size of the tank will vary. So we need to give this provision to see to say what is the tank minimum level and maximum capacity. Finally, you have a graph which will tell you like how many hours of pumping has happened, how much quantity of water, when the pump was turned on, turned off, and all that. Please scroll down, sir. Please scroll down, sir. Yes. So this is a schedule. You can set the start time, end time, and specify the duration or run minutes. So you have 4 slots: slot 1, slot 2, slot 3, and slot 4. 4 slots are there. So you can set 4 schedules. Once the schedules are set, every day the schedule will be operated automatically. So this is login for one pumping station. So like this, there will be logins for all the pumping stations, and you can go and monitor and control the pumping stations remotely from this web application. So this is the solution that we are proposing for IoT-based water network management, where all the pumping stations are monitored and controlled remotely from the web server. So this is the in-depth detail of the application that I am sharing. Anybody has some doubts, you can ask me. The presentation of the solution is over. Anybody has some doubts, you can ask me.
Participants, if you have any queries, put it in the chat box or raise your hand so that we can unmute you.
How to store the sensor data? The IoT gateway has an internal EEPROM memory. It will record all the data into itself. Whenever there is internet connectivity, it will transmit all the data from its internal memory. So whenever whenever there is internet connectivity on 4G, all the data in the internal memory will be transmitted to the server, and thereafter the data will be stored in the server only. It will not be stored on the IoT gateway. Suppose there is cellular network problem, suppose there is no coverage, or sometimes when it is rainy, there is no signal and all that. In such times, all the data will be stored or logged into the internal memory of the IoT gateway. We have an internal EEPROM. On top of it, there is a micro SD card also inside. So gigabytes of data can be stored inside the SD card. Again, when the cellular connectivity is regaining, all the data along with the date and timestamp will be transmitted to the server. So this is how data is being handled on the IoT gateway and on the server. We don't want to miss even a single data from the of the process. So we will store it in the IoT gateway first. And once data is received by the server will give an acknowledgement to the IoT gateway. Once an acknowledgement from the server is received, the gateway will delete the data within itself. So this is the process. And Dr. Madhuri is requesting to unmute.
Hello, sir. Madhuri Mule here. Sir, at water treatment plant, we have the SCADA system, right? So SCADA is again the supervisory control and data acquisition system that we have.
Yes.
So in SCADA system also, we are using such sensors.
Yes. In SCADA also, you are using such sensors, but the difference between SCADA and the solution that we are proposing right now is SCADA involves a lot of PLC. There are programmable logic controllers, PLCs involved in SCADA. These PLCs are known for not so flexible kind of programming. You need to know the PLC ladder programming logic. You cannot have fuzzy logic at all on this the PLCs. And to connect the PLC to the server, again you need another simple IoT gateway is required. So what we are proposing is, instead of having a combination of PLC plus IoT gateway, we will remove both of them and give them an IoT controller, which means the IoT controller is the gateway and the controller itself.
Okay.
What will
Sir-
happen with this is speed of communication will be good. Quickly, the server can issue commands and immediately the IoT gateway will take action on top of it.
Okay, sir. Sir, can we have the water quality modeling using IoT?
Yes, you can connect the water quality sensors also. Total dissolved solids, TDS, pH, chlorine level.
Where we need to
dissolved
install these sensors?
You can connect all these sensors to our IoT gateway itself. It has provisions for all of that. So we are not only talking about quantity of water, we are also talking about quality of water.
Yes,
So we know
yes.
whether the water has been properly chlorinated. Nowadays, there are gas chlorination plants that are coming. So if you just oversee it,
Yes.
a lot of chlorine will be mixed. So we need to see the ppm of chlorine dissolved in the water and all that.
Yes.
So water quality sensors like dissolved oxygen, oxides of sulfur, total dissolved solids, turbidity, all these sensors can be connected to the IoT gateway. So as you measure the quantity of water, you will also be measuring the quality of water. This will give you additional
Quality of water.
This will give you additional information where a particular water is getting
Hello,
spoiled.
sir.
Audible? Am I audible?
Yes, sir.
Yeah. So this will
So
give
you
you
are audible only.
Yeah, this will give you information on as the water flows from one town to the other, where the water quality is getting adverse. So you can specifically go to that point and see who is contaminating the water there.
Okay, sir. Sir, I'm interested in doing project for such water quality analysis, sir. But how to, have these IoT gateways, and I don't have much knowledge about these IoT gateways and
You can reach out to me.
everything.
You can
So
take
how
my
can I
contact
proceed for this?
You can reach out to me personally. You can take my contact. You can take my mail ID from the coordinator.
Okay, sir.
And you can reach out to me personally. We'll talk
Sure,
about
sir.
this.
Sure, sir. Thank you, sir.
Welcome.
Thank you so much.
Anybody else having some clarifications? Okay, can we close the session?
Yes, sir.
Thank you, everybody. Thank you for bearing with me during the technical glitch that I was facing. Thank you for bearing with me. Thank you. I hope this information was at least a little bit informative.
It was. Shall we conclude, sir?
Yes, please.
Kind words are short and easy to speak, but their echoes are truly endless. I hope that his echoes are truly endless for us by his wonderful session. In this way, I would like to thank our today's resource person, Mr. T. N. Raj Vignesh, for providing a wonderful technical session. Thank you very much, sir.
Welcome.
And I also like to thank all the participants who helped us to complete the day 3 of ATAL-FDP.
So Raj Vignesh, sir, thank you, sir.
Thank you, sir. Thank you. Bye.
Participants, the feedback and attendance link for today's session, day 3, session 3